You can scan a QR code upside down, sideways, on a curved coffee cup, at a weird angle, in a mirror, with a company logo slapped right in the middle of it, and even with a whole corner ripped clean off. And it still reads, instantly. That is not luck, and it is not your phone being clever. That resilience is engineered into the pattern itself. You can destroy up to about 30% of a QR code, and it will still hand over the exact right link. Those little squares are not random. Almost every part of the pattern has a job, and once you know what each piece does, you will never look at one the same way again. Look at any QR code, and the first thing you notice is 3 big squares, one in the top left, one in the top right, one in the bottom left. Those are called finder patterns, and they are the reason the code works at any angle. Each one is a square inside a square inside a square, a black ring, a white ring, a solid black center. And that layout is deliberate. If you draw a straight line through the middle of one, in any direction, you cross the bands of black and white in the same ratio every single time. 1 part black, 1 part white, 3 parts black, 1 part white, 1 part black. That 11311 signature almost never shows up by accident in a normal image. So your camera doesn't hunt for a QR code. It sweeps the picture looking for that specific ratio. And the moment it finds 3 of them, it knows that's a QR code and those are its corners. And here is the clever part. There are 3 finder squares, not 4. The one missing corner is the whole trick. 3 points can only form one kind of right angle. So the instant the scanner locks onto 3 corners with an empty 4th, it knows exactly which way the code is turned. Upside down, rotated 90 degrees, held up to a mirror, it doesn't matter. The 3 squares tell it which end is up before it reads a single bit of data. Finding the corners tells the scanner where the code is and which way it faces. But it still has a problem. How big is the grid? Is this a tiny code with a few rows or a dense one with 100? And what happens when the code is printed on a curved cup or photographed at a slant, so the squares aren't even squares anymore? 2 more built-in features solve that. First, the timing patterns. A single line of alternating black and white squares running between the finder patterns across the top and down the side. It looks like a dotted line, and it works like a ruler. By counting those alternating cells, the scanner figures out exactly how many rows and columns the grid has, so it knows precisely where every cell should sit. Second, on all but the smallest codes, you'll spot smaller squares sprinkled through the pattern, each one a little bullseye. Those are alignment patterns. They act like survey markers. When the code is bent around a cup or shot at an angle, the scanner finds those known markers, sees how far they've drifted from where they should be, and mathematically unwarps the whole image back onto a clean grid. That is why a code wrapped around a curved bottle or stuck on a wrinkled sticker still reads. The scanner isn't guessing, it's using fixed reference points to straighten the picture back out. Now for the part that actually holds your link. Strip away the corners, the timing line, and the alignment markers, and everything left is the data. A field of black and white squares. Each little square is called a module, and each one is a single bit. Black means 1, white means 0. That's it. A QR code is a picture of 1s and 0s laid out in a grid. The scanner reads them in a set path, snaking up and down through columns of 2, starting from the bottom right and winding across the code. It collects that long string of black and white bits, groups them into bytes, 8 bits at a time, and those bytes turn into numbers, letters, a web address, whatever the code was built to carry. There is no magic in the data itself. It's binary, the same 1s and 0s running through every computer, just printed instead of stored on a chip. You are literally looking at the raw file, in ink, with your own eyes. Here's the question that trips people up. If the link is spelled out in exact black and white squares, how can a coffee ring smeared across the middle, or a logo covering the center, or a torn-off chunk not wreck it? The answer is the best idea in the whole design. Error correction. When a QR code is made, it doesn't just store your link. It also runs the link through a piece of math called Reed-Solomon and stores a batch of extra recovery squares alongside the real data. Those extra modules are like a spare, calculated so that if some of the data goes missing or gets misread, the scanner can rebuild exactly what was lost. It's the same family of math that keeps a scratch CD playing and lets deep space probes send clean photos back across billions of miles. And you get to choose how much protection to bake in. There are 4 levels. The lowest can recover from about 7% damage. The highest can recover from roughly 30% of the code being destroyed. That is the secret behind those QR codes with a logo dropped in the middle. The designer cranked the error correction up to the high level, which means almost a third of the pattern can be blocked or ruined, and the scanner still reconstructs the full link from what's left. The coffee stain, the ripped corner, the sticker over part of it, none of it matters as long as you stay under that threshold. The code is carrying its own backup. A few smaller pieces finish the machine. First, the quiet zone, that blank white margin around the whole code. It looks like empty space, but it's required. The scanner needs a clear border to know where the code ends and the busy world begins. Print a QR code with text or a picture crammed right up against it, and it can fail purely because there's no quiet zone to frame it. Second, size. QR codes come in versions, from the smallest 21 by 21 grid up to a giant 177 squares per side. Bigger version, more modules, more data. A small one holds a short link. The largest can pack in thousands of characters, a few kilobytes of text. The more you stuff in, the denser the grid gets. And third, tucked right next to the Finder patterns, is a strip called the format information. Before the scanner can read a single bit of your data, it reads this first, because it's the instruction label. It says which error correction level the code is using and which mask was applied. A pattern flipped over the data to keep the squares from clumping into big blank blocks that could confuse the reader. The format info is so important, it's stored twice, in 2 places, so that even if one copy is damaged, the scanner can still find the instructions. So put the whole thing together in the half second it actually takes. Your camera sweeps the image and hunts for that 1:1:3:1:1 ratio. It finds 3 Finder squares, sees the empty 4th corner, and instantly knows the code's position and rotation. It reads the timing line to size the grid, uses the alignment markers to unwarp any curve or tilt, and reads the format info to learn the mask and the protection level. It lifts the mask, snakes through the data turning black and white into 1s and 0s, runs Reed-Solomon to repair anything the coffee stain destroyed, and out pops your link. All of that, from a smudged code on a curved cup, faster than you can read this sentence. So it's brilliant and nearly indestructible. But it is not safe, and this is the part worth taking seriously. A QR code is just a link you can't read. That is the whole problem. Your eyes cannot tell where a code points, so you are trusting it blind, and scammers know it. There is a fast-growing con called quishing, QR code phishing. Criminals print malicious codes on stickers and slap them over the real ones on parking meters, restaurant tables, EV chargers, and public posters. You scan what looks legit, land on a fake payment page, and hand your card details straight to a thief. The fix is simple discipline. Your phone shows you the actual web address before it opens. Read it. If a parking payment code sends you to some random misspelled site, stop. Never scan a code taped up in public without a second look. 2 more honest limits. QR codes need decent contrast and focus. Low light, a crumpled sticker, glare on a screen, or a printer that smears the squares together can push the damage past even that 30% ceiling, and then nothing reads. And there's a privacy angle people forget. A marketing QR code can quietly log that you scanned it, where and when, feeding tracking you never opted into. The code is honest. Whoever made it may not be. So let's kill the 2 big myths. Myth 1. A QR code is a random mess of squares. It's the opposite. Almost every region has a job. 3 corners for orientation, a dotted line for scale, little bullseyes to unwarp curves, a quiet border, an instruction label, and only then the data, wrapped in its own self-repairing backup. Nothing in there is decoration. Myth 2. Your phone is doing something magical to read it at any angle. It isn't. The intelligence is printed into the pattern. The code tells the camera which way is up, how big it is, how to flatten the curve, and how to fix its own damage. The phone just follows the instructions the code is holding up. That's the whole thing. A grid of black and white bits, framed by 3 squares that fix its orientation, calibrated by a ruler and a set of markers, and armored with enough spare math that you can tear off a third of it and still get exactly where it was sending you. Just look before you leap. Subscribe to Whambox for more How Does It Actually Work explainers.